Okay, topic for today, relations and functions. First thing we're going to do is talk about what a relation is. And a relation is just a set of ordered pairs. And we just went around the room. We found people's birthdays. The first coordinate, that x-coordinate over here, is people's months. And this x-coordinate over here is people's days. And that's all we did. We put them together. And this is a set of ordered pairs. We're going to go back to... All right. Now we got to talk about functions. A function is a relation in which no two ordered pairs have the same first element. If we could, somebody from the room, please volunteer. Can you give me an example of a function? Give me 2 or 3 coordinates that would make a function. Okay, 3, 2. What else? 7, 8. One more. 1, 5. Yeah, these guys together create a function. Yes, this guy's a function because all the x coordinates are different. Let's also take that down. So we just had a great question. Somebody asked, okay, so can the x's and the y's repeat? You know, which matters? It's okay for the y's to repeat, as in the case, as in this case. Suppose I put 6, 5 down. This would still be a function, but it's not okay for the x's to repeat. So this right here is an example of something that's not a function, and it's not a function because the x values in the front, those first coordinates, repeat. All right, so what's written in red is that I just had to write the numbers over again because nobody could see in the back. So I just wrote the question in larger font. Here's what we're going to do. Part 1, A. Is number 1 a function, yes or no? Yeah, number 1 is a function because we have no x values that are repeating each other. What about number 2? Is number 2 a function, yes or no? No, number 2 is not a function because check it out. Whoops. Sorry, let me go back to a different color. Number 2 is not a function because we have 2 1s that are repeating itself, and so it doesn't qualify. It's not a function. Okay, so we got to solve parts B and C now. Parts B and C, they ask about domain and range, and we just talked about something, the fact that, you know, this is just vocab. Domain refers to the x-coordinate. Another fancy word for domain is the inputs. Range corresponds to the y-coordinates, and that's also just a fancy word for the outputs. And so now we're going to go about trying to figure out, in question number 1, which numbers are the domain and which numbers are the range. All right, piece of cake. So that's what we did. We just went through B, the domain. The domain is 1, 2, 3, and 4 because those are the x-coordinates. And the range is 1, 4, 9, and 16 because those are the y-coordinates. Okay, now let's do number 2. Let's do number 2. This should be an A, by the way. I messed that up. That should be an A. Okay, let's do 2. B, what's the domain of this one? Yeah. The domain of this one is 1 and 0, and we don't need to put the other 1 in there. Okay. You can if you want to. And what's the range of this one? Yeah, the range is -1, 0, and 1. Perfect. And those funny-looking brackets that I'm using on all of this, those funny-looking brackets are for solution set. It's just the math fancy way of putting a big box around your answer. Record. Okay, so the vertical line test. Right now I'm going to show you what the vertical line test is, and then we're going to take some notes on a description of what of it. And so a vertical line test basically does the following. In the example that came before this, we looked at a bunch of coordinates and decided whether they were a function or not. But how do you do that when you're given a graph? You could try and write down every coordinate. That would take forever. The best way is to do the following. Take a vertical line, and for you guys it would be a pencil or a pen, and sweep it through the graph. If it hits the graph more than once, in this case it does, it is not a function. Because if you tried to put down these 2 points right here, you would get x values that are repeating. So if it hits more than once, it's not a function. Okay, so people got confused. So we're going to look at another example as to whether something is a function or not. Let's take our vertical line and let's sweep it through. Does it hit more than once? No, it doesn't hit more than once, and so yes or no, is this a function? Yes, it's a function. Let's do this one. All right, one more time, we're going to decide whether this is a function or not. Let me highlight what we're talking about. We're talking about that right there. Let me grab my vertical line, because that's what I need for my vertical line test. And we're going to sweep it through and decide whether it's a function or not. So take your pencil or pen or whatever straight thing that you have. Let's sweep, and it's good, and it's good, and it's good, and right then and there it's not, because it hits twice at the same point. See that? And so let's decide. Is this a function? Not a function. Hold on one second. So then, like, right now we tried to describe the vertical line test in our own words. The vertical line test, let's recount what we just talked about, tests whether a graph is a function or not. And what you do is you draw a vertical line, or you take your pen or your pencil and you sweep it through. If the vertical line only hits the graph once at each spot that you're sweeping through, then it's a function. And if it hits the same spot at two different points, then it's not a function. All right, on to domain and range. We're going to describe this graph using domain and range, using interval and set notation. Okay, so let's look at the graph for a minute, right? The graph starts at 0 right here, okay, in terms it's the x values, and travels along and goes all the way down to what? Goes down to 5. So we could say to ourselves, oh, the domain of this graph is every x value that exists between 0 and 5. And we have to write it this way because there's lots of numbers in between. When you guys get up to real high math, they talk about the number line being extraordinarily dense in between whole numbers. Half, a fourth, a fifth, a sixth, a seventh, an eighth, a ninth, a tenth. There's an infinitely many numbers in between, and you could not write it out. This is called interval notation. Interval notation. Now, another very smart person came along and said, well, it's really kind of annoying to write stuff out like that. And here's what they did. They said, I can shorten this bad boy up. I can shorten this up. You know what? I'm going to say the same thing, but I'm going to say it like this. That's the domain right there. Now you see what I mean about the brackets. The brackets really matter. This is known as set notation. And from here on out, you're allowed to use set notation. Set notation works like this. If you were thinking about using these symbols, those are closed circles, and they correspond to hard brackets. If you were thinking about using these symbols, okay, those correspond to soft brackets. Last part about this. All right, guys, last part, and then we're going to be done for today. We're going to talk about the range. The range. What's the range of this particular function? Yeah, the range, you're right, 0 is less than or equal to, now range is which coordinate, x or y. Super important that you remember that, which is less than or equal to 5, because if we look at our graph, the y coordinates start here at 0 and go all the way up to 5. If we're going to try and represent that in interval notation, once again, hard bracket on 0, all the way over to 5, and hard bracket around 5 because it's less than or equal to something. My bad. Somebody pointed this out. Let me make a correction. This bottom kind of notation over here is set notation. Thank you very much.